One of the elements of this course I always enjoy most is the conversation about good and misleading visualizations, primarily because you guys are so good at finding misleading visualizations. And I already posted an announcement in the course about good and misleading, summarizing the main points in the discussion. But I thought it would be useful for us to look at some of the highlights of that discussion as well, in particular at some of the reasons that visualization can be misleading. So how can visualizations be misleading? Well, the first option is, of course, to come up with the wrong chart. For example, a pie chart to compare absolute values. And in this case, because respondents can have a favorable opinion on more than one candidate, the total adds up to more than 100%, and that's misleading. If the question had been a forced choice question, like which of these three candidates do you have the most favorable opinion about, then the total would have added up to 100 or maybe a bit less, and then a pie chart would have been appropriate. Another one that I liked a lot as an example of a misleading visualization is the inappropriate use of 3D shading. The use of a pie chart in this case is appropriate because we're showing market share in the US smartphone market. That is, we're trying to show how the US smartphone market is made up of different slices, namely the market share of each manufacturer. However, by using a 3D pie chart, it suggests that the slice in green, which is Apple, is larger than the slice in purple, which is other manufacturers. Whereas in fact, when you look at the underlying data, you will see that Apple had 20% of the market share and the other manufacturers had 21% of the market share. In other words, the market share of the other manufacturers was slightly larger than Apple, even though in this chart it suggests that Apple is larger than the others. The other issue, of course, is the colors in this pie chart make this one impossible to understand for certain people with certain form of color blindness, and we'll come back to that later in this session. Another ways in which you can mislead your audience is by mapping values inappropriately. The message that this visualization is giving or should be given is that gas prices have risen more slowly over the last 4 years in India. However, the use of the column chart suggests that they have fallen in absolute terms as well, because typically a column chart maps absolute values. Whereas in fact, in absolute terms, the gas prices have, of course, continued to rise. Another way in which you can mislead is by mapping irrelevant information. So the map on the left shows the presidential results in 2020 by county. And it suggests that Trump did indeed win the election with an overwhelming majority, because the majority of this map is red. The problem, of course, is that land doesn't vote, people vote. And if you look at the map on the right, where we not only map, which not only maps who voted for whom by way of color, but also how many people voted by the size of the bubbles, you will see that Biden must have won because more of this map is blue than is red. Another one that I like a lot is mapping two measures that have nothing to do with each other. In this case, the number of individuals diagnosed with autism and sales of organic food in $1 million. And it suggests that, or it's purported to suggest that organic food sales will cause, and that organic food will cause autism. Although you could, of course, also argue that a higher incidence of autism leads to an increase in organic food sales. These issues are completely unrelated, and mapping them on the same graph is misleading. Another way in which you can mislead is have an inconsistent scale on the axes. And this has this in two ways. The y-axis is not consistent because the difference between 7 and 9 million is about the same difference as between 13.5 and 15 million, although of course the difference is more than 25% higher between 7 and 9 than it is between between 13.5 and 15. The other one is that the time along the x-axis is not mapped consistently. So the difference between September 08 and March 09, which is 6 months, is about twice as large as the difference between March 09 and June 10, even though that is 14 months. It's probably also the case that what this maps is cumulative job losses, not absolute job losses. But if you look at the title, it seems to suggest that we're looking at absolute job losses by quarter. If this is true, then in June 10, about 50% of the American working population, maybe even more, would have been unemployed. Another way to mislead is no information on an axis at all. And this is again the Charvitz Planned Parenthood graph that we saw, I believe, in Module 1. It suggests that in 2010, the number of abortions overtook the number performed by Planned Parenthood, overtook the number of cancer screenings and prevention services. Whereas if you look at the absolute numbers, that's of course nonsense, and we already looked at how to fix this graph. Here's another one, starting an axis at an arbitrary point. What this graph suggests is that the average height of women in Latvia is about 5 times that of the average of women in India, because the Latvian lady is 5 times as large as the Indian lady. Was in fact the difference is between 5 feet for a woman, an average height for a woman in India, to 5 feet and 5 inches for a woman in Latvia. In other words, the difference in height is just 5 inches, not a factor of 5, as the graph suggests. Here's another one, and this time we have the corrected version as well. So the one on the left suggests there has been a dramatic increase in interest rates, whereas the one on the left, which starts and the one on the left, as you see, starts at 3.14. But if you start at 0.00, as the one on the right does, then you see that the difference in interest rates has actually been pretty minimal. Now, that does not mean that you always should start at 0. Sometimes not starting at 0 is justified. So here's a graph from, I believe, the National Policy Review publication that is one of these climate change denying organizations, where they mapped the annual global temperatures in Fahrenheit. And it looks, they start at 0, they go to 110, and it looks as if there's hardly been any change in global temperature. Of course, 2 things wrong with this. The first one is that average global temperature has never been 0 or 110. So starting at 0 and ending at 110 is inappropriate. Given that average temperature started at around, global temperature started at around 57 degrees, you would certainly be justified starting the chart at 50 degrees or maybe even 53 degrees. The other issue, of course, is that small changes in annual global temperature have large consequences for the climate. So a change of 2 degrees Celsius or 3.6 degrees Fahrenheit, scientists tell us, will have a disastrous consequence for climate. And it's therefore appropriate to show really small differences as well. So sometimes you can justify not starting at 0. The final way in which I think you can mislead your audience is by flipping the direction of the axes in, for example, a line chart. So normally what we would expect is that the higher the point in the line chart, the higher the value. But you see that in this graph, they flipped it. What it suggests is that after 2005, the year in which Florida enacted its Stand Your Ground law, the number of gun deaths went down. Whereas in fact, if you look carefully at the axis on the y-axis, you will see that they actually went up from just over 500 to just over 800. So again, by flipping the direction of the axis, you can mislead your audience.